Welcome to Study Loop.
In this question, it is told that a light string is wound several times around a spool of mass m and radius r, and it is told that the free end of this string is attached to a fixed point and the spool is held so that the part of the string is not in contact with its vertical. Now we have to find the acceleration of this spool. So we can say that equation of motion is given by, that is, from equation of motion, net force, that is mg minus tension force, is equals to, this is mass into acceleration, taking torque about the axis passing through the center of the spool and perpendicular to it. So we can say that net torque is equals to, this is I into alpha. So torque is due to the tension force, so this is T into R is equals to, this is I into alpha. Now we can say that I is the moment of inertia, so this is half mr square into alpha is given by, that is A by R, as we know that A is equals to R alpha. This is T into R. From here we get the value of T, and this will comes out to be half into MA. Let this is our equation second and this is our equation first. Now put the value of T in first. So we can say that put the value of equation 2 in equation 1, and we get, this is mg minus half ma is equals to, this is ma. From here we get the value of acceleration, and this will comes out to be 2g by 3. So this is the acceleration of this pole, and this is our answer. So we can say that for this question correct answer is option B. Thank you.